You're listening to Don't Waste Water.
I had walked away from my master's program with a business plan, with a first place prize in the Tufts 100K competition, about $10,000 in bank account, and no idea what I was doing.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
30-minute freshwater rinse or a very mild bleach and caustic, and you will fully regenerate the membrane back to its starting performance. Cycle after cycle, whether you throw tens of thousands of parts per million oil and grease, whether you have protein, whether you have anti-foam agents or silicone surfactants, we have seen an amazing ability for the membrane to regenerate and continue operating, even in some of the streams that a classical membrane would say it's going to be dead in hours.
I'm your host, Antoine Walter, and in today's episode, I'm excited to welcome Alex Rappaport as my guest.
You can't, sadly, dump a bunch of flat sheet membrane or even modules on the floor of an industrial plant, pour water over them, and hope to get filtration. Unfortunately, that is just not the way these systems work.
Alex is the CEO and co-founder of ZwitterCo.
We have one main commercial product we're selling today, which is our SuperFiltration membrane. That's not all that this chemistry can do. That's certainly not all of the kinds of tools and products that we'll offer.
ZwitterCo leverages the benefits of Zwitterions to build membranes that treat the world's toughest wastewater. Theoretically speaking, wastewater treatment is easy. You have water with stuff inside at the inlet, and you want water with much less stuff inside at the outlet. So you just have to define what has to be removed, and you could size a membrane to do exactly that job. Let's say you want everything that's larger than 1 nanometer to be out of the picture. You take a reverse osmosis membrane, you push your wastewater on one end, and whatever comes out on the other end will fit your specification. Easy, the job's done, goodbye. Well, the problem is that if that system was to work, it would for sure not work long. Your membrane would be clogged and irreversibly fouled, and after minutes to hours, you would have to throw it away and start fresh. Now, nobody except me would be stupid enough to try something like that. So in most cases, you won't go for a one-step treatment, you'll rather opt for a clever combination where stuff gets removed from water layer by layer with optimized efficiency. Stages of this process will probably be done with membranes, and if you want to end up reusing that water, the last step will for sure be done with membranes. But even if you have this time designed everything right, your membranes will still clog over time. And backwash will lose efficiency cycle after cycle until irreversible fouling is so high you have to replace your system. So every 7 to 12 years, to give a ballpark figure, you're good to reinvest in membranes, modules, and some peripherals. Unless someone cracks the code for fouling-free membranes. But that's physically not possible, right? Well, that's before looking into the surprising physical properties of Zwitterions, a special family of molecules that are simultaneously positively and negatively charged. As a result, they're highly hydrophilic and very resistant to non-specific adhesion. So wouldn't that make them the best special sauce to pump up a membrane filtration system? I'll let Alex answer this in a minute, as he'll do it so much better than me. But you'll swiftly notice that it's a fascinating take at the toughest wastewaters and most difficult industrial reuse riddles. To that extent, ZwitterCo is a perfect example of innovation with impact. If that's a theme you'd like to explore in greater depth, innovation with impact is also the tagline of the upcoming BlueTech Forum happening in Edinburgh on the 17th and 18th of May. The agenda is packed with great speakers, mastermind roundtable sessions, innovation for impact box design sprints, 5x5 partnership case studies, lots of networking opportunities, and BlueTech's signature cherry-picked disruptive water tech innovations. That's just a bite-sized summary of a packed agenda. If you'd like to know more, check out bluetechforum.com. The link is in the description, and consider joining me and many former guests of this podcast in Edinburgh this May. I talked of cherry-picked innovation. Well, there's a cherry on the cake as well. With the code Antoine20, like my name followed by 20, you'll get a 20% discount on your registration if you book before the end of April. Again, all the links are in the description. I'm looking forward to meeting you in Edinburgh. And for now, I'll let you dive into my conversation with Alex Rappaport. I'll meet you on the other side.
You're listening to Don't Waste Water. the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Alex. Welcome to the show.
Excellent. Glad to be here. Thanks for having me.
I have a first riddle that you need to answer for me. I heard that the word Zwitterion comes from the German. So do you pronounce it like the Germans, like ZwitterCo, or is it ZwitterCo?
It is ZwitterCo. I will say we have had several members of our larger circle who have German roots, and I have often been getting the linguistic lesson about the origins of our company name. Yeah, Zwitter actually has some meaning in scientific usage here. The ions are both positively and negatively charged. Zwitter, as a German word, refers to both the hybridization, right, the positive and negative there. So the science checks out with the language.
So that was a teaser into what we might be discussing later on, but I have traditions on that microphone, and it starts with the postcard. So what can you tell me about the place you're at, which I do believe is Cambridge, what I would ignore by now?
Absolutely. So we're actually right on the outskirts of Cambridge, Massachusetts. Actually, our headquarters is in Woburn. And one of the beautiful things that I get to see on my drive to work every day is that we are right outside the Middlesex Fells Reservation, which is this large forest and reservoir that I get to drive through. So you have this beautiful vistage of water, the way I start my day before coming into the office. It's a wonderful place to get to see.
So does that mean that you have a history with water, or how did you encounter that topic? Was it at university? Was it before university? Was it after university?
Yeah, so it did precede university. I can't say that I ever wrote on a middle school, what do I want to be when I grow up, as someone who works in membranes. But I did know that I wanted to be in clean tech, right, in sustainable technologies. And part of where my love for the environment, for the natural world, and how that ended up folding into my career path was I was a river raft guide. I used to teach whitewater stand-up paddleboarding to campers, aged 7 to 15. It sounds scarier than it is, but it is standing on a paddleboard in the middle of class 3, class 4 whitewater. A couple very scary near-miss scenarios there. I used to spend all of my summers on the Potomac River outside of the Maryland, D.C. area. And so those experiences, the communities that were built, spending so much time in nature, and then knowing, obviously, that there's a whole bunch of challenges in the world that we're experiencing, that was why I went into environmental engineering, and that was some of the passion underlying birth of ZwitterCo.
So going into environmental engineering, that's one thing, but still going into entrepreneurship in that field isn't the common route. Might be more developed nowadays than it was a while ago, but still, when did you decide you wanted to be an entrepreneur? Was it from the beginning of your university days, or at some point you thought, oh, that's really so cool, I have to create a company out of that?
I really hope at some point some of my old environmental engineering professors get to hear some of these stories, because I was not the student that they might have expected would have ended up actually pursuing a career in environmental technology. Let's say I would not have been the first on that list. I obviously loved the discipline, and I loved the idea of technology for solving environmental challenges. Entrepreneurship was my second love at school. I come from Tufts University. A lot of the technology and the team members at ZwitterCo also came from Tufts. So I was the head of the undergrad entrepreneurship club. I had the fortune to build relationships with a lot of the professors in the entrepreneurship and engineering management departments at Tufts. And when I was first exposed to the idea of actually doing rapid prototyping, rapid business model development, Lean Six Sigma, the concepts that help you organize how you would build a venture and how you would take technology through the rapid commercialization pathway, that dovetailed with engineering as engineering as the medium and entrepreneurship as the force. And the two of them together, when I had the opportunity, when I sort of stumbled upon the technology that now is the basis of what we work on at ZwitterCo, it was a wonderful match between there was something that had this vast performance enhancement and that could be used for these incredibly challenging industrial wastewater treatment opportunities, and that was just at that nascent stage of something new had been made, but it had only been at the stage of lab scale technology, patented work. There had been no commercialization plan organized. So I got to take a lot of the learning that I had built over the last few years in early stage venture development and apply that to something that I cared so deeply about, which was doing work in the water space.
You mentioned how a lot of the people working with you today also come from Tufts University. If I'm right, that's the case of your co-founder, but not exactly at the same time than you. So what's the story? Where do you meet?
Yeah, sure. So Chris Drover is my senior by a few years. I won't age him too far, but he was previously at Doble Engineering and then at Oasis Water, which in its own right was a company that had really been pushing the boundaries on membrane technology, working on forward osmosis for brine concentration. And so as Oasis and that journey was winding down, he had really well connected his experience within the chemical engineering world at Tufts. And the invention behind ZwitterCo's technology is a novel material, right? A new chemistry for membranes, and that had come out of one of the research labs out of the Chem department. So I had been spending the last couple semesters working on building the business case for how we would go scale and commercialize and gain funding to support the growth of the company. And I had walked away from my master's program with a business plan, with a first place prize in the Tufts 100K competition, about $10,000 in the bank account, and no idea what I was doing. So it was about that point that I started working more closely with Aisha Asatakan, the professor who invented these new class of materials. And we had been working together on what is going to be the path to first prototype, to first scaled up process, to first customer test, and how do we replicate and better create quality structures around the things that they were doing by hand in a lab. We needed to transfer to industrial scale production. We had been tossing some ideas around. I came up with, let's call, some not so intelligent ideas about how you scale membrane technology. And the more she was sort of aware of the needs we were about to go under, the more important it was that we started to really build the technical firepower behind the company. So she actually connected me to Chris Drover. And that was a wonderful first union as we think about all the challenges that we had in our first few years, figuring out what this chemistry really was, how we would end up translating it to something where you could be producing miles of membrane under really well-controlled circumstances, and that we knew how to tune and tailor the performance to the different applications we cared about. Chris has just such a wealth of background, everything from the organic chemistry to the design for manufacture to running R&D operations to the development of intellectual property and so much more. So that was one of the things that helped us all jump off a cliff together as I was graduating, as we were forming the company, was the knowledge of the sort of collaborative skill sets that we were each bringing into this.
You mentioned several times the material which is at the core of what you're doing at ZwitterCo. What is it? Is it the Zwitterion? Is it the polymer? What is this core special sauce?
It is a Zwitterionic copolymer, two core backbones to the material. What we refer to as the copolymer is actually a class of materials. So there are different kinds of compounds or constituents that you can include within that sort of base idea of the recipe. But the copolymer is the active layer, right? So we are using pressure-based tangential flow filtration, the same way that you would think about for any other flat sheet or spiral wound membrane configuration. But the difference is the active layer that actually encounters the wastewater is made from this Zwitterionic copolymer. So what it does, the way it works, why it has the performance it has, is the relationship between the Zwitterionic group and the hydrophobic group that it is copolymerized with. So let's do a first quick story on Zwitterions and why they're relevant here. Zwitterions are some of the most hydrophilic materials known to man. They are positively and negatively charged by definition. That means that they behave like a salt, or they have strong affinity to interact with polar solutions like water, and that allows them to be really hydrophilic. The Zwitterions we use are actually so hydrophilic, they're hygroscopic. We have to operate in a desiccant chamber when handling them in certain circumstances because they'll wick moisture out of the air and swell into a gel. So you have this material that loves water. If you made a membrane just out of Zwitterions, it would dissolve immediately, which would not be very effective for filtration, right? And so different attempts to integrate hydrophilic compounds and Zwitterions specifically into membrane chemistry has been something that people have been exploring over the last couple decades. Most of the attempts have been post-processing methods, grafting of these Zwitterionic chains onto existing polymer bases. And the challenge that was found in a lot of those use cases was superficiality, that it both helped create some surface improvement, but that it was not something that was super long-lasting and robust. And when it comes to the reason why membranes or filters clog, why they are often experiencing challenging operations or failure modes when you throw lots of fats, oils, and grease and other challenging compounds at them is not just that the surface fouls up, but you actually have pore penetration. Stuff gets stuck inside the matrix of the membrane. And when you do a surface treatment of zwitterionic style coating, that's only the two-dimensional layer at the very top. You need the whole three-dimensional structure to be fouling resistant if you're going to really change the way that a membrane is operable. So now you enter in the sort of second half of the equation, which is the zwitterionic group is copolymerized with a hydrophobic group. And what you get here is, because those two groups have such different energetic behavior, you can institute a self-assembling property where as our membrane is formed, the zwitterions will orient themselves to become the pores of the membrane. So this is no longer just a surface level alteration. The pore structure itself, the passageway that water transfers through, is all zwitterionic. And so you have this sort of hydrophobic glassy matrix with salt channels in it. And those salt channels, because they are so hydrophilic, you could imagine if a water molecule and an oil molecule are both competing for surface interaction, and you have the surface is all zwitterionic, it wants to grab onto the water. It wants to hold onto the water and stay fully hydrated, almost acting like a shield or a water barrier that keeps any of those organic compounds from ever hitting the surface, sticking to it, and staying there long enough to form that clogging behavior. So when we clean our membranes, because what you're doing is basically shearing off any stuff that gets stuck to the surface or agglomerates in that first place where the wastewater meets the active layer, what we get is 30-minute freshwater rinse or a very mild bleach and caustic, and you will fully regenerate the membrane back to its starting performance. Cycle after cycle, whether you throw tens of thousands of parts per million oil and grease, whether you have protein, whether you have anti-foam agents or silicone surfactants, we have seen an amazing ability for the membrane to regenerate and continue operating, even in some of the streams that a classical membrane would say it's going to be dead in hours. And that's all because of how well those zwitterionic channels allow you to keep unimpeded pores, unclogged matrix of the active layer.
The last time on that microphone that I spoke with someone addressing gels, hydrophilic, hydrophobic, that was with Gerald Pollack, and we discussed his set of research about the fourth phase of water and beyond. And I have to wipe that out of my mind. Is it the same topic we're discussing here? Is it an adjacent topic, or does it have really no link at all?
I am afraid I'm not close enough to that material to be able to comment. I will say there's a lot of work that's been done on hydrophilic materials, and that behavior of hydrophilicity as a property that can help with things like fouling resistance, or that can help allow you to lubricate certain operating environments. That's a well understood behavior or phenomenon. Seeing it actually in a sort of robust, commercially available product, I think there's a lot of other sort of examples that you can point to. If you look at some of the quantitative metrics that you'd use to determine surface wettability, our membrane is well above any other competitive product in terms of that behavior showing up.
So you had this base material, so this zwitterionic copolymer, which you put together, the hydrophilic, the hydrophobic together. When did you decide that has to be a membrane? And when did you pick the application field for that discovery?
The first fundamental invention was on the basis of trying to produce a membrane, and particularly a membrane that was going to solve the Achilles heel of filtration, fouling, clogging. So when I was first introduced to the research, there had been lab scale membrane coupons that had been developed and that had been run on some high strength wastewaters or some fouling prone feeds. And there was evidence that the cleaning behavior, the ability to recover, was vastly different. So the use of this material as a thin film layer was sort of understood, and there was some evidence of its value as I came into the picture. As we thought about driving that towards something that could be a product, we had to, while maintaining the elegance of the hydrophilicity and the self-assembly, we had to figure out how to re-engineer a lot of that to be something that could be turned into a product that could work on roll-to-roll web conversion, that was going to hold up in the kinds of environments from a temperature and a solvent and various different kinds of constituents that you'll see in industrial wastewaters. So that was really the way we took the engineering forward from that initial lab scale prototype, was towards the kinds of environments and use cases where it was going to be able to have that value realized by end users. Which then, second part of your question, we did a whole bunch of studies. We took a whole bunch of samples from a whole bunch of really smelly, vibrant wastewaters from every industry for whom you see the common signs of it's a tough wastewater, so I'm hauling it away by tanker truck. It's a tough wastewater, so I'm throwing it down the drain and paying surcharges. It's a tough wastewater, so I'm not reusing anything in it, whether it's the organics or the water. It's just an operating cost to my facility. We saw this in obviously the produced water space, in meat, poultry, seafood, in agricultural wastes like digestate. You see it a lot in ethanol. You see it in a lot of bioprocesses. So those markers of organics as the limiting feature of the water from doing something that looks more like reuse or looks like valorizing that waste stream, those were some of the first indicators that this membrane might be able to perform a separation that was going to be valuable. But you only get that insight as you start interacting with those fluids firsthand. So one of the earliest investments that we made was creating a laboratory environment where we could be taking in 5 gallons of wastewater from various sites at a time and running bench style studies that could give you, you're now removing this much BOD, COD. You're having 100% removal of all suspended material and oil and grease. You're able to unlock using something like reverse osmosis to get you down to potable quality or reuse quality water because you've removed all of the organic material that would have otherwise compromised that use of reverse osmosis. So those kinds of exposures to the different waste environments helped us begin to characterize how the go-to-market model was going to evolve, because now you could understand status quo, you could understand the operating costs, you could hear the level of urgency or pain from folks who had no other sense of what tools they could apply to these challenges. And it's one thing if it's just a cost center, but when folks are running out of water, when they're in violation, when they are seeking to pioneer sustainability in their field, you see this. I've never had to walk into a customer conversation and convince them that doing something more interesting with their water was a good idea. Those days are long gone. So helping just partner on, now there are new tools and now there are new capabilities that we can bring into the idea of an integrated solution for you. That conversation was often met with a lot of positivity and a lot of interest, even for folks who had never really seen membranes in action before.
I'll come back to that customer experience, which, by the way, it seems to me like whether you've been very lucky, really you've met the right people, but still I wouldn't say it's the norm yet. It's maybe becoming more, but not yet the norm. I'd also like to readdress your go-to-market. I think there's one important step with Mist, which is you explain how you have this copolymer and how the Zwitterions themselves are the pore, but still those pores could be any sizes. And usually we find them from cartridge to reverse osmosis through microfiltration, ultrafiltration, nanofiltration. You mentioned forward osmosis, and you have a different concept, which is SuperFiltration. So what's that thing?
Certainly. I will say, and my marketing people are probably going to yell at me for saying this, we did not invent SuperFiltration. We didn't even come up with the term. So the first indication that from a communication exercise, we needed a different way to talk about this membrane is because it ended up being quite a mouthful to say, well, it's like a tight ultrafilter. It's going to give you low pressure operations. It's going to be really easy to clean. It's going to be very chemically tolerant. Also, it's doing nanofiltration level organics removal. It's not desalinating. It's not taking out divalent ion species. So you wouldn't use it for an NF application, but it's going to give you better permeate quality than you expect from a UF. How's that sound for a product? And that was the genesis of, can we give the industry new language to think about why this separation profile is different? So it is roughly 1,000 Dalton molecular weight cutoff, or about a 1 nanometer pore size. Part of the way the membrane is manufactured gives you a really good distribution or homogeneity in the size of pores and where those pores line up on the active layer. So we get a very precise ability to fractionate compounds larger than a nanometer. They really all come out smaller than a nanometer. They all really pass through. And it's not doing the kind of desalination or partial ionic separation that you'd expect from an NF level separation. So as we were thinking about where this separation class is relevant, you get a lot of interest in things like protein rejection, right? Proteins that are in that low thousands of Dalton range, you can suddenly get very high yield, very high retention, even of protein fragments or peptides that are all valuable products that you might want out of a bioprocess or out of a dairy stream. And when it comes to wastewater applications, you see UF, MBR, these kinds of separations being sufficient in certain circumstances to pre-treat or to really help you get to those final tertiary polishing stages. But there were also a handful of use cases where we were finding loose or mid-scale UF wasn't enough, that enough dissolved organic material was passing through even a UF, and that was showing up as you're cleaning your RO every day or every week, or that you're going to experience more severe chemical requirements in those cleanings. So we think of superfiltration at that very lowest possible edge of ultrafiltration, or tight ultrafiltration, as what could produce the most ideal feed water for RO, what's going to get you full removal of fats, oils, and grease and suspended solids, what's going to get you really excellent protein yields and ash passage, but that's not going to have energy penalties that you get from NF or RO, and it's not going to have the cleaning restrictions that you also typically have from polyamide chemistry. You can really chlorinate our membrane, lots of tolerance to wide pH ranges, different acid-base combinations, as well as oxidizing agents.
So if I try now to put you in a box, sorry about that. You mentioned how you're tolerant to organics. Obviously, you don't have this problem of irreversible fouling. Probably that helps you with the OPEX over time, with the lifetime of your membrane. Still, the water ecosystem exists for decades. So whether you found really a niche which was unaddressed, and I'm very concerned about this industry because that means we were really polluting stuff for the pleasure of doing it, or you're still living in someone's space and eating up that space and replacing an existing technology. To me, you named one of the suspects to that, which might be the MBRs, which you could, as you explained, have probably better OPEX than an MBR and similar characteristic, physically speaking. The other one might be dissolved air flotation. Is there any other one which you might be eating up, replacing, disrupting? You decide what's the best term.
Yeah, you could think of ceramic or inorganic membrane products as the other common tool that you point to for challenging waste streams that you could otherwise think of ZwitterCo as a tool for.
That's a difficult one because I had regularly ceramic membrane people on that microphone predicting how they would wipe out polymerics. So if now a polymeric player says that he can take on ceramics, then we're in a circle.
Well, how many different companies over the years have said things like performance of a ceramic at the cost profile of a polymeric? I mean, this is an age-old discussion that there's probably more nuance and gray area than any one black and white answer. I'll give you an even more frustrating or it depends style answer for this, which is I have seen now too many examples in each different industry that we operate in where the thing you thought you were competing with over here is a complementary tool to you over here. That I truly feel there is such a vast blue ocean of the need for new advanced treatment showing up in a lot of these applications where, again, land application, direct discharge, municipal discharge, hauling, or some other form of offsite disposal. These are all features of, I'd say, a very large majority of where we think about industrial wastewater management today. So the compilation of new tools that help provide you an integrated solution where you're not just getting clean water, but you're also creating feedstocks and fertilizers and other value-added co-products as you go through these different stages of processing. That introduction is going to mean if I'm in dairy wastewater, and I have a lot of lactose and other low molecular weight sugars, maybe a biological process as part of that treatment train makes sense to consume those easy to digest sugars. If I'm in landfill leachate, maybe what you really want is just the easiest way to concentrate all of that leachate through a membrane-based process before taking it to a thermal process so you have something semi-solid going back to the landfill. If you're in anaerobic digestate out of manure or food waste, you may want something like a stainless steel microfiltration to take out fiber before you go to ZwitterCo or RO to do the nutrient capture and to get you down to clean water. So it has shown us that the thoughtful integration of the right tool for the right job is an output on my optimist hat, is going to prove to us that there is not a zero-sum game here, that it is not one tool will dominate over another. Even air flotation, which I would say in a lot of the food wastewater applications, reducing the chemical payload on a DAF by having a membrane barrier afterwards that can take more heavy organic effluent from that DAF is one of the things that we've looked into, or even eliminating the DAF entirely. In some cases, that makes sense. In other cases, we have some partners we work with who use chemical-free DAF as a way to create a non-contaminated byproduct that can be sent to rendering or that can be otherwise turned into some sort of fat or lipid feedstock to a biodiesel process. And you actually want that DAF performing that function, and then the membrane takes all the effluent from there. And a DAF that might otherwise be perhaps a little less reliable in what kind of effluent quality it has, or that is not going to be able to adapt as easily to changes in the industrial conditions at a plant, suddenly you've used a membrane to protect against that weakness of the DAF while using the DAF for what it's good at, which is a very low cost way to extract a decent bulk of the solids and fats, oils, and grease that's in that stream. So I know there's always like in front of investor slides, a competitive matrix. Here's all these other tools and here's all the X's on all of them. And ZwitterCo's got all these green check marks. But as many an esteemed water scholar has said, it's a complex set of problems. And you really want to have the right kind of open-mindedness to which tools help get you the overall process efficiency.
Don't get me wrong. I'm a water guy, so I would fully support your answer, which is the right answer, but I'm still going to push you in a corner if I'm meeting you in an elevator. So you really have just, and I'm not going very high with that elevator. So you really have like 10 seconds.
Yeah.
And there is one clear advantage of your technology, which you do know is the reason why people come to you. What is it?
In 5 years, we've never found a fluid that permanently fouls the membrane. The diversity of organic heavy streams that we have been able to process and enable water reuse for the first time has shown up in so many applications.
Okay, I guess I would stay.
How many floors did we just go up in that elevator? Was that good?
I would stay a bit longer and maybe forget where I was going at first. So I win on that one. You explain how your membrane brings that value. Now, when I spoke with several membranes company on that microphone over time, most of them started saying they wanted to build a membrane and then found out they had to build a module just because the membrane itself wouldn't be integrated that way. What's your approach to that?
There's a great quote. Oh, I'm going to blank on the author of this. We toss this one around the company often. You can't, sadly, dump a bunch of flat sheet membrane or even modules on the floor of an industrial plant, pour water over them, and hope to get filtration. Unfortunately, that is just not the way these systems work. So you really got to think about your position in the value chain, right? This is where we bring the most amount of expertise and competency and ability to continue pushing the boundaries on what performance is possible. Certainly lives at the membrane level, but to deliver something that others can easily integrate and use, you need to give a module. And so we've made choices to go far enough into the value chain to make sure that the thing we're going to give someone looks and feels similar to the thing that they would have otherwise had to buy. So you're going to make that friction of trying something new as low as possible. In our go-to-market concept, the follow-on question from there is, so do you build the system? How far do you go into system engineering? How far do you go into project delivery? And this is where you start being honest with yourself and with your organization and what you're good at. There's a lot of companies that are a lot better at project delivery than ZwitterCo could be. We don't have that kind of building block in our DNA to go build buildings and pour concrete and manage all of that project delivery process. And meanwhile, we have a growing cohort of really close partnerships with just top tier, very high caliber engineering firms who are able to bring some of those other complementary unit operations that with ZwitterCo often as a cornerstone of these processes, or that helps bolt on some really valuable new capability. They're hungry for having a new tool in their toolkit that lets them provide greater value to their customers and into the water industry. So that's a moment where, is there anyone providing what we feel is this differentiation in the quality of filtration that's possible and how these tools can be built to do all sorts of new separations? I think that's a place where ZwitterCo shines. Is there an existing value chain for how wastewater treatment engineering projects get delivered? And are there a handful of very well acclaimed, strong balance sheets, strong engineering teams, strong existing set of complementary tools to bring to bear? Absolutely. So we sort of stopped at the module and we said, we can do a lot with membrane science, even a lot with module science. And we're going to make sure when we work with a partner, when we work with an engineering company, we're not just going to hand them a module and a spec sheet and say, good luck, tell us when you've sold a couple $1 million. We spend a lot of time thinking about all of the other ancillary services, documentation, know-how, tools, processes to help us integrate into the way they sell and the way they think about validating a new technological process.
So that would mean that you're not integrator agnostic because you want to make sure that it's integrated the right way. It's not like just it's on the market, just buy it.
The current form factor of the SuperFiltration that we sell today is a spiral wound element that in theory will fit into standard pressure vessels and that you would think of in a similar design concept to how you might put together like a dairy UF system. High recirculation, multiple stages, achieving very high concentration factors. That's a common and fairly generic design basis to start with. But there's so much more that goes into not just the delivery of a new solution, but even the mindset and the mentality around innovation and around risk sharing and around how you finance these projects. So while we love to and growing the number of systems partners that we work with, we do think very carefully around the kind of investments we make. We are a small, young company, and so we have a certain amount of bandwidth that we can support for partnership onboarding, and we want to really make those partnerships successful. So we focus a lot of our attention on bringing leads to our partners, to bringing additional services to our partners, to making sure that if they're going through a first engineering design where ZwitterCo's membranes are built in, that we're there with them sort of every step of the process to help fill in some of the gaps in how you think about best optimizing the system. So it's hard to say that we're integrator agnostic or not. It's sort of the relationships, the capabilities that we've seen from some of our top partners right now are just a wonderful collaboration and sort of common mentality, common shared purpose around the needs of the industry are changing so fast. There's so many opportunities. Let's really enjoy the sensation of feeling like all of our work collectively matters and that our teams are dedicated to this mission. And that's a point of synchrony between our various organizations. That framework, that mindset to go about these projects is often one of the best indicators of partnership success.
Maybe agnostic isn't the right way to define it. I'm thinking, of you could go to, let's take an example of municipal tender, which I do know is not exactly where you're fitting into. But if you go into a municipal tender, you can convince the end user that he needs your membrane module. And then he's going to make a tender in which it's written that whoever can take the tender, but the modules have to come from ZwitterCo. So that would be one way to be fully agnostic, because at the end of the day, you don't care which EPC gets the job, you would be part of it. The other extreme of that would be you do like Royal Haskoning does with Nereda, which is to have some licenses, which they would then hand out to one particular EPC, and then that EPC is the only one in the country allowed to leverage the technology, which is, I would say, that the highest level of partnership you can have. If I understand, you're somewhat in between, in the sense that really anybody could pick it up because the form factor is really agnostic. But then when it comes to taking and extracting the most out of the technology, you have a certain bandwidth and you cannot train everybody at the same time. So you're going step by step, educating the market.
Yeah, that's a really good summary. We're probably not in the middle. We're probably further towards that really close partnership, almost a license model. I understand the analogy there. Just because also the partners that we've worked with who have invested their own time, their own resources into developing these applications, we want to protect, the way that they have invested their time in channel development, and we want to make sure that they're the group that we really work on go to market. So it helps them also appreciate, regardless of the structure of the agreement, that we're really bought in on them and their success. And you just don't quite have that same relationship with your key partners when you're anyone, we sell anything to anyone and you're all just going to compete together. I would also argue that's kind of the history of how commoditization in the membrane industry has happened, is you lose touch with a value strategy or value pricing analysis, both because of your disconnect with the end use application, the way that you organize your partnerships. It's everyone wins and value can be maintained when you're really thoughtful with your channel strategy.
You mentioned how these partners invest in you, which makes me like a weird bridge, but I'm taking it still.
Sure.
You just closed the Series A, which is the largest ever in the water sector.
Yeah.
So you mentioned how you have a limited bandwidth today, given the size of the company. I guess that's history now. You just raised $33 million. So what does that change?
One of the really exciting announcements we'll be able to make very soon, so I'm going to give you a little sneak peek here, and part of what was a primary use of funds from this round is that ZwitterCo has, and will be operational very shortly, a 30,000 square foot production complex here in Massachusetts, what we refer to as our innovation center, the Technology Innovation Center. And the purpose of this facility and all the capabilities inside is a co-location of all of our offices, all of our laboratories, and also a significant space for prototyping and product scale-up. So we have one main commercial product we're selling today, which is our SuperFiltration membrane. That's not all that this chemistry can do. That's certainly not all of the kinds of tools and products that we will offer. We will offer products that look more analogous to what you might classically think of for ultrafiltration, nanofiltration, RO, et cetera. And the speed of product development is all about owning your manufacturing process, owning that scale up, learning how each different piece of equipment has to be operated at what tolerances under what quality paradigms, and that we can do that iteration and maintain that learning and do so as fast as possible. So our goal with this facility is to actually have production capability from the polymer to the membrane to the elements to the quality testing, so that we can go through those learning cycles in under a month. A new polymer formulation comes out of the lab and is immediately turned into coating fluid and is immediately turned into membrane, is immediately turned into elements that we're testing. And that speed and that ability to continue pushing the boundaries of what the chemistry is capable of, now with a lot of the incoming feedback from partnerships and from the adoption in the marketplace and seeing how the membranes are performing, is helping us move on a couple different product enhancements rapidly. And that's part of the promise of what our company is trying to be, the source for continuing innovation in breakthrough filtration and continuing to give more and more tools to solve more and more challenges in water. So as we think about use of proceeds, one of the major features was building this center and all the sort of capital and operating costs that go around with that. And then, of course, building out some of the other elements of our commercialization, whether it's sales and marketing teams, our pilot fleet, all the other things that help us put our tools in front of as many end users or as many partners as it makes sense to do so. So it is, I'd say, a really exciting stage of growth for us. You raise a round like this, it definitely builds a lot of expectation, but the goal is to not just show the immediate value created from current products and to show that we can enable water reuse and show that we can provide a practical, economically viable means to address challenges in a number of industries, but also to show that as a company, we are building the engine internally, the habits, the framework, the processes that allow us to continue that kind of innovation in the years and decades to come. And that's what is sort of underneath all of what we're trying to do at ZwitterCo.
You mentioned the decades to come. You've said product enhancement before. Does that mean that you will enhance the existing product, or will you build a complete product range?
Stay tuned for some announcements later this year, Antoine.
I take it. You mentioned the pilot fleet and the sales and marketing. What's your go-to market with that regards? Do you have to start with a pilot every time? Or can you also just do a lab analysis and say it's going to work and then own your words and come with some process guarantees?
We actually are pretty involved with our partners and in project delivery on how we think about different risk sharing models. So we definitely will stand behind the fouling resistance, the chemical tolerance, the permeate quality we can produce. But piloting serves a number of different values and virtues. And I know many a water startup has struggled with the just length and frequency of pilots required. There's been more than one book written on like death by pilot in this space. One of the things that we are seeing is that repeat installations in the same kind of industry or application, especially if we have a strong partner who is the one sort of leading the charge in how we go from our 5th digestate project to our 50th. The cost of sales, the timeline, the amount of unknown and uncertainty around how the process is really going to shape out, given different site constraints or different nuances of the project, that diminishes pretty quickly over time. So there's a decent amount of upfront investment, and we want to make sure we can always walk into a new opportunity or a new partnership discussion and be able to bring all the knowledge and capability of our team around our systems and unit operations, which is why we maintain our own pilot fleet. But a lot of times pilots are collaborative, where we'll bring the SF system, someone else is bringing the RO or the evaporator or the coarse filtration, and we will make sure that we have a joint understanding of what assumptions have to be true for the economics and the performance to make sense. And we're validating that on testing, both for everyone's benefit, right? We're now going to walk into a risk sharing agreement, and this is the first time they've ever seen zwitterionic membranes. It's a big ask. And so we want to know that they've seen the data as well to think about how they're going to spec that into their projects. So I don't think this is a unique answer. And this is probably true in a lot of the new technology adoption processes. There's more upfront learning and risk sharing and demonstration that's required. But I think we're already seeing in some of our more mature applications, turning the corner on pilots as a investigation or exploration, as opposed to pilots as just a point of final validation.
On the business side of things, when you raise $33 million, where does that put you in terms of valuation? 150, 180? You cannot disclose?
It puts me somewhere on a beach right off the coast of Bermuda. Very nice drinks. Yeah.
People listening to that won't know that you're not joking, that you're
I'm
actually on the beach. I
100%
see it
joking.
on the camera. But yeah, it's obviously a fake office.
Yeah, I mean, valuation is really not what we focus on or think about in these kind of contexts. It is the credibility that comes from these kinds of announcements and the kind of stakeholders that are supporting us. It's the ability to have the resources to go solve all sorts of new problems and really accelerate, sort of pedal to the floor on product development. That's the value of a round like this, is you both catapult forward in how others are aware of what you can offer, and you're able to really bring the kind of firepower and capability you need into these tough projects.
The reason why I'm asking is that you're an award-winning entrepreneur. You are Forbes 30 under 30. You've just led the biggest funding round for a Series A in the water industry. There's one achievement nobody ever did in that water industry. It's to build a unicorn. Never happened. I don't know if that matters, honestly, but still, never happened. So is that a path you might be setting yourself on?
You know what would be really cool? And genuinely, I'm not just trying to give a flippant answer, but truly what would be so motivating to us and to the team is to be able to do three things. One, to be able to prove water as an investable thesis, right? To be able to start having a different outcome when new water entrepreneurs are trying to put the logo salad on their slides in front of investors of all the different outcomes that led to great investor returns. I would love for this to become a beacon or a lighthouse that helps bring more dollars into this space, bring more hungry young minds into this space. Two, I would like to make sure that those who have invested so dearly into ZwitterCo, into me personally, from a mentorship, from an advisory, from a networking perspective, not just the investment of dollars, but there's been such a collection of experienced veteran serial entrepreneurs who have helped me on so many different chapters of this journey. I would love to see us be able to help provide the returns that helped be the baseline for why there was so much effort invested into ZwitterCo in the first place. And then probably most importantly is I would like this to reach a scale where we're not just talking about a story, right? We're not just talking about the idea that one day industries are going to be off the water grid, that they're going to have their own independent, resilient supply of water that, will be safe even in the face of water scarcity and climate change, that, we're actually seeing impact recognized on a scale where it shows up on NASA satellites and where it features in water policy. You achieve those things, and I could not care less whether it's labeled a unicorn at the end of the day.
You mentioned jokingly the beach. Now I have to crack the secret. You're not really on the beach. I had on that microphone Andrew Benedek a while ago, and he explained with different time frames than yours, because it was a different era. So he had to walk in the desert for much longer, I think.
Probably.
But he really built up Xenon from nobody believes in membranes to the point where MBRs were in the middle of the market. And he sold off Xenon to GE, and he went to the beach for 6 months. And then he got tired of being on the beach and being retired, and he came back. And the rest is history, because now he's leading Energia and bringing it to the same level of size and he's over 70. So I guess when you're made of that bread, of that wood, or whatever you're made of, usually there's a stronger driver than just ego or numbers. So I like your three cardinal directions. Right now, how many are you working for ZwitterCo?
How many employees do we have?
Yes.
54.
How many do you think you will be in 5 years?
Well, there's a lot of fun decisions that are going to help baseline that answer as we grow. Level of international expansion, level of additional product capabilities that we think about in our insourcing and outsourcing strategy. You're probably measuring well into the hundreds at this point, but that's, again, it's all about the destiny of what the technology can do and what the industry needs. I think we are certainly attentive to, we want to continue growing in a way that is really collaborative with the industry. So some of the things that can really drive headcount up are when you're starting to build service depots around the world and engineering offices, and you're doing more of that project management or program management. And I think, in certain applications or certain industries, maybe there will be more of that you see at ZwitterCo, but where we are at the heart of new technology development and the facilities that we require to do so, I think is really harmonious with the way that a lot of the rest of the industry exists to then take that technology and apply it all over the world in different applications.
So let me hand you over my crystal ball. So you're in 2028. You have a town hall meeting with those hundreds of people now working for ZwitterCo. And you have a PowerPoint, hopefully not a PowerPoint. You have
we're all in VR at this point, yeah.
Yeah, and you're just sharing the good news with your team of what you've achieved and how you've had an impact. What is on the first slide of that VR or hologram?
There's certainly a counter of just millions of gallons a day reused. There's a counter of number of other sustainable initiatives that have been accelerated because of the availability of the tools we provide. Things like plant-based proteins, renewable natural gas, green chemicals, all of these other spaces that need their water best managed in order to help them reach the heights that they're trying to reach. There would be something about the kinds of new fertilizers, new feedstocks, new products, the amount of value created that would have otherwise just been waste lost. And there would probably be some way to, we're talking 2028, let's get really ambitious here. I'd like to be able to relate this back to percentage of Ogallala aquifer no longer lost because of the amount of industrial adoption of reuse tools and of the kinds of interconnected systems that help us better manage and predict how climate patterns and weather patterns are going to induce scarcity in different places. And so there's more and more incentive for folks to think about trimming or constraining their water consumption to best manage on a watershed level or on a regional level what's going on.
Well, that's a future I'd like to see. So I wish you all the best on that route. I think you are well prepared to take it on. Thank you. Thanks a lot for the openness in the discussion and everything you shared in that deep dive. To round it off, I propose you to switch to the last section, which is the rapid fire questions.
It's time for the rapid fire questions.
So in that last section, I try to keep the questions short and your duty is to keep the answers short as well. My first one is, what is the most exciting project you've been working on and why?
We have a poultry reuse project that is getting not just a terrific partner into the mix, bringing what we believe will be the most cost-effective model to get you all the way to slaughterhouse reuse that has ever been seen in this industry, but we're also bringing into that project a lot of support and an investment from the regulators that will be involved in the permitting process. And we are seeing not just the enthusiasm from the customer, from the partner, and from our team, but we're seeing the regulators also saying this is exactly what we need people working on, and this is the direction we need to take our reuse initiatives.
Can you name one thing that you've learned the hard way?
Only one. Come back to that point on value chain. It's really important early in venture development to have some hypothesis about who you're trying to be when you grow up. I'll admit, there are, in several prior chapters, times that we try to do more of the complete solution development or integration ourselves, and knowing how tough it can be to solve process challenges in wastewater, it has been really fruitful to find the kind of mind sharing collaboration with partners who have the other half of that equation that doesn't necessarily make sense for us as a component supplier in the value chain.
Is there something you're doing today that you will not be doing in 10 years?
I'm sure most of what I'm doing today, I won't be doing in 10 years. And that's just a truth of the constant deconstruction and reconstruction of your role as a company goes through different chapters. Obviously, I will always have a strong hand and love and care about people and our culture and how we operate as a company. I'll always have my investor facing and financing partner relationships. I will always have the strategic leadership of company direction and of the executive team. Hopefully I'll be on more and more of these podcasts as the spokesperson to the world. But I mean, we are already seeing different levels of middle management show up. We're thinking about different dynamics in interdepartmental processes. And as we grow and as sort of the foundation comes up from beneath us, I will, by necessity, be less and less involved in some of those ground floor operations.
Aside from Zwitterionic membranes, what's the trend to watch out for in the water sector?
I mentioned it just a moment ago, the idea of this watershed level management. I have a lot of inspiration from folks that are working on things like a third-party marketplace for water. How do you audit the trail of a single drop of water so that as we start working on city level planning or regional level planning, we could think about the instrumentation, the modeling, the financial marketplace and incentive structures needed to help us work together on this challenge of water management. I think there's a lot of work happening in marketplace design. I know there's good and bad in the way that carbon credits have been implemented, but you could sort of imagine a similar concept. And that's going to be necessary to make sure that there are drivers in place to get people to financially motivated to take some of these decisions and to think about different pros and cons on water conservation.
And last one, would you have someone to recommend me that I should definitely invite as soon as possible on that microphone?
I was looking through the list of past participants and I was curious, have you guys met with Tom Ferguson from Burnt Island Ventures?
He promised that I could catch him at the next Blue Tech Forum.
Oh, you have to.
He promised at the last Blue Tech Forum that I would be able to catch him, but he's in the MC, so he's very busy. But this time it's on both our agendas.
If you think I talk fast, track the words per minute that comes out of Tom Ferguson. Really impressive. I mean, Tom's just a lightning rod in this industry. He's so well connected and has so much to bring. I'd also recommend, when the time is right, the financing partners at DCVC who helped ZwitterCo, achieve what we've achieved, have a really thoughtful thesis about the role they can play in helping to shape the future of the water industry. And they've published quite a bit on the journey that they're taking. And I'd be more than happy to make that connection if you want to talk to a slightly different player in this space.
That would be fascinating. So if you have a recommendation, I'll follow that. So thanks a lot. Again, I mean it. It was great to have that conversation with you. You mentioned how you might be doing more of those podcasts in the future as an advocacy level or as a water voice. Well, that microphone is open whenever you want to come back. So I'd be happy to document the next stages of your journey.
Excellent. I appreciate that.
So thanks a lot and talk to you soon.
Terrific. All right. Take care. Have a good one. Cheers, everyone.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.